Quadratic equations. So in the past lectures we discussed the basics of the quadratic equation. So in this lecture we'll discuss the topic in the quadratic equations is sign of the quadratic equations. Okay, the sign of the quadratic equations. We know that the roots of the quadratic equations. Okay, so if the roots of the quadratic equation, let's consider the quadratic equation as ax square plus bx plus c equals to 0 is a quadratic equation. Then if the roots of this quadratic equation, or the first condition I am considering it is as the roots are complex roots. Okay, if the roots are complex roots. Okay, so what is the condition? If the roots are complex roots, when the roots are said to be complex roots for a given quadratic equation, so we know that the values of the roots of this quadratic equation is minus b plus or minus square root of b square minus 4ac by 2a. Now the roots are said to be complex or imaginary roots when if the discriminant b square minus 4ac is less than 0. Okay, if the discriminant b square minus 4ac is less than 0, we can say that the roots are complex roots. Okay, so which also be can be written as, so how it can be written as 4ac minus b square is greater than 0. Okay, which is also be written as 4ac minus b square is greater than 0. Okay, now we will try to convert the given quadratic equation as, so we are considering ax square plus bx plus c, which quadratic equation, if we take a as a common, then we can write it as x square plus b by a into x plus c by a. Now we need to get the condition such that the b square minus 4ac has to be appear in this simplification. Then how to we'll get it as, then we can write as, which is a into and x square plus, so what is a square plus 2ab plus b square, which is the a plus b whole square formula. Now we are having in place of a square we have x square plus, and again the x is present over here, the x is present over here, and in place of b we have b by a, and to get is as 2 over here, it should be multiplied and divided by 2 now, which can be written as 2 times of b by 2a into x. Then again the resultant is b by x into b by a into x, that is not changed, then which is 2 times of b by 2a into x. Then now, okay, so what is a square plus 2ab plus b square, so what is here b by 2a whole square, which has to be added and subtracted. Now b by 2a whole square is subtracted, and we have what it is, c by a left over here. Okay, c by a. Now we can write this is as a times of, okay, a times of, now this can be written as, this part can be written as x plus b by 2a, x plus b by 2a whole square. Is it clear? So a square plus 2ab plus b square, which is in the form of a plus b whole square. If we expand this, x plus b by 2a whole square, x square plus 2 into b by 2a into x, b into 2 by b into x plus b by 2a whole square. Okay, that is good. Now what is the left over here? Now c by a is a term minus what it is, b square by 4a square. Okay, b square by 4a square. Now if we simplify this, what we'll get over here, which is equals to ax square plus bx plus c equals to a times of what is x plus b by 2a whole square plus if we take, right, what is it is 4a square as a common. Okay, if we take 4a square as a common, then what we'll get? 4ac minus b square. Okay, 4ac minus b square. Okay, now which can be written as ax square plus bx plus c by a. Okay, ax square plus bx plus c by a. Now I'm taking this into the LHS side, equals to x plus b by 2a whole square plus, what is this, 4ac minus b square by 4a square. Okay, 4ac minus b square by 4a square. Now if we consider the condition over here, so what is this 4ac minus b square? Okay, just before the condition we obtained, this is as 4ac minus b square is nothing but the condition we obtained over here, it is now, which is 4ac minus b square is greater than 0. Okay, 4ac minus b square is greater than 0, which is the condition when we considers the given roots are complex roots. Okay, the given roots are complex numbers. So now come back to the case what we obtained here. From, if the roots are complex, the b square minus 4ac is less than 0, which also can be written as 4ac minus b square is greater than 0. Now the condition what we obtained over here, the condition we obtained is, so now this is the condition. Okay, so here the 4ac minus b square, this term is positive, which is greater than 0, and a square, whatever the value of a, okay, whatever the value of a, the by 4a square is also positive. Then we can say that this total term is positive, that means which is greater than 0. Okay, if the roots are complex, we will obtain it is as 4ac minus b square as greater than 0. Then a square, 4 times of a square, whatever it is plus or minus 4a square is also positive. Okay, then we can consider over here what it is, x plus b by 2a, it is square. Square means now this term is also greater than 0, which is also be a greater than 0. Then we can say that ax square plus bx plus c by a, now totally which is greater than 0. Okay, ax square plus bx plus c by a is greater than 0. Now when this happens, so now the ratio sum, what is x by y is greater than 0. When the x by y is greater than 0, only the case if x is positive and y is positive, then plus by plus it is plus, that means greater than 0, and x is negative and y is negative. Okay, x and y both are negative, then again it is 0. Okay, now we can say that if the roots are complex, if the roots of ax square plus bx plus c equals to 0 are complex, okay, if the roots are complex, then what it is, ax square plus bx plus c and the coefficient of x square, that means a, where a is nothing but coefficient of x square. Okay, a is coefficient of x square, will have same sign. Okay, will have the same sign. Okay, which is the important one. Okay, if the roots of a given complex number ax square plus bx plus c are imaginary or complex roots, okay, then we can say that the ax square plus bx plus c and the coefficient of x square a will have the same sign. Okay, I think now you understand this. Okay, so next we will consider the case 2. Okay, next we will consider the case 2. The case 2 is if the roots are, okay, if the roots are equal. Okay, if the roots are real and equal. Okay, if the roots are equal, what is the condition we need to obtain the roots are equal means? Yes, the discriminant is greater than 0. The discriminant is, sorry, the roots are equal means, what is the condition? The roots are equal means the discriminant is b square minus 4ac is equals to 0. The discriminant equals to 0. Okay, so just before we obtain the condition, what the condition we obtained? Ax square plus bx plus c. This is the case. Okay, ax square plus bx plus c by a is obtained as. Okay, I'm writing over here. It is again. So what is the condition we obtained? Ax square plus bx plus c by a equals to what is the condition? X plus b by 2a whole square plus 4ac minus b square by 4a square. Okay, now the condition we are checking for b square minus 4ac equals to 0 means whatever it is 4ac minus b square is also 0. Then we will get it as x plus b by 2a whole square plus 0. Okay, simply which is nothing but ax square plus bx plus c by a equals to x plus b by 2a whole square. Okay, now which is the condition over here? This is nothing but if whatever it is the square x plus b by 2a whole square is always greater than 0. X plus b by 2a whole square is always greater than 0. Why? Because it is a square. Square root of anything is always a positive. Then we can write it as what it is, ax square plus bx plus c by a is greater than 0. Okay, which is greater than 0. Okay, that means if the roots are, now I am writing the statement as if the roots are equal. If the roots are equal, okay, then ax square plus bx plus c and the coefficient of x square. Okay, the coefficient of x square, that is nothing but the coefficient of x square is nothing but ax square plus bx plus c and coefficient of x square greater than 0. When the case is possible, only that both have, okay, both have same sign. Okay, if ax square plus bx plus c and a have the same sign, then we can say that the roots are real, except what is the condition here? Except at x is equals to minus b by 2a. What happens if x is equals to minus b by 2a? This condition will become 0. Okay, this condition will become 0. Okay, now we discuss the two cases. The first case is if the roots are complex, then ax square plus bx plus c and the coefficient of x square have the same sign. If the roots are equal, ax square plus bx plus c and the coefficient of x square have the same sign except at x is equals to minus b by 2a. Now go for the third condition. What is the condition here? The roots are real and distinct. The roots are real and distinct. Okay, roots are real and distinct. Okay, roots are real and distinct. Let we are considering the roots of ax square plus bx plus c equals to 0 as the roots are alpha and beta. Let we are considering the two roots alpha and beta, and here we will consider the case 1 as again in this one the first condition. The case 1 as the first case when this x, okay, if the x lies between alpha and beta, okay, what happens if the x lies between alpha and beta, the condition, okay, what happens if x lies between alpha and beta? What we can express as ax square plus bx plus c can be expressed as in terms of alpha and beta as a times of x minus alpha into x minus beta. Okay, I think this is well known to us. Okay, we can represent the ax square plus bx if the two roots, any quadratic equation having the two roots alpha and beta, if it is having the two roots, the quadratic equation can be written as x square minus of sum of the roots into x plus product of the roots, and which can be written as x minus alpha as a factor size x minus alpha into x minus beta. Now we can write this is as ax square plus bx plus c by a equals to x minus alpha into x minus, okay, into x minus beta, okay, x minus alpha into x minus beta. Now we need to analyze over here what happens to the sign of these if the condition is alpha less than x less than beta. Now the condition is what it is, alpha less than x, that implies x greater than alpha, that implies x minus alpha is greater than 0. Okay, the condition we obtained it is as x minus alpha is greater than 0. Then what is the another condition, x less than beta. Okay, x less than beta means what is this, x less than beta means x minus beta less than 0. If we take into the LHS side, we can write as x minus beta is less than 0. Now clearly that ax square, if the value of x lies between alpha and beta, if the value of x lies between alpha and beta, that means from this one we can write it is as alpha must be less than beta. Okay, keep in mind that if the x value is lying between 1, that means alpha and beta means, for example, 1 less than 2 less than 3. Okay, we are considering to explain this condition, we are considering 1 less than 2 less than 3. So that means from this one we can write as 1 also less than 3. Okay, so if alpha less than x less than beta, that means alpha less than beta. Okay, alpha less than beta. Now, so one is positive, okay, one is positive and another one is negative, then the product of these two results is, okay, the product of these two results is negative, that means which is less than 0. So we can say that ax square plus bx plus c by a is less than 0. So when this happens, ax square plus bx plus c less than 0, okay, what is the condition? So means only the resultant ratio of x by y will be a negative. Okay, the condition must it satisfy either x is positive and y is negative, or x is negative, y is positive, then we will get the condition as x by y as negative, x by y as negative. So now that means x and y, the ratio numerator by denominator must be a different sign, opposite sign. So we can say that ax square plus bx plus c and the quotient of x square will have opposite sign. Okay, will have opposite sign. Okay, will have the opposite sign. Okay, is it clear? Now the case 1 we considered as alpha less than x less than beta. Now go for the case 2. What is the case 2? Okay, the case 2 is, now the case 2 is x less than alpha or x greater than beta. In this case, what happens? X less than alpha or x greater than beta. So now I am considering the first case. So x less than alpha, that means x minus alpha is less than 0. Okay, x minus alpha is less than 0. But before the case itself, we consider alpha less than x less than beta, obviously alpha less than beta. Okay, so now for example, so considering and x less than beta, so x less than alpha, if it is x less than alpha, so the case I am considering it is as x is equals to 1 and alpha equals to 2, and the case is alpha less than beta. This must be a considered case. If alpha less than beta means I am considering, so 2 less than, for example, beta equals to 3. Okay, 2 less than 3. So that means from this one we can say that x less than beta also. Okay, so if x is less than alpha, the case we are considering, from this one we can say that x minus beta is also less than 0. Okay, x minus beta is also less than 0. Then what happens over here? Ax square plus bx plus c by a equals to x minus alpha into x minus beta. So which is a negative? Less than 0, and this one is also negative. So that means the resultant is positive, greater than 0. Ax square plus bx plus c by a greater than 0. When it is greater than 0? When ax square plus bx plus c and the quotient of x square will have the same sign. Okay, if these have the same sign, then this is the condition x less than alpha and x greater than beta. So now the next case is x greater than beta. That means x minus beta is greater than 0. Okay, x minus beta is greater than 0. We can say that obviously x minus alpha is also greater than 0. Okay, if x greater than beta, then x minus beta is greater than 0 means obviously x minus alpha is greater than 0. Then we can say that ax square plus bx plus c by a is equals to x minus alpha into x minus beta. Now which is a positive and x minus beta is also positive. Then what is the result we are getting? It is as ax square plus bx plus c by a is also positive. Okay, the greater than 0 means now the numerator ax square plus bx plus c and the quotient of x square will have the same sign. Okay, will have the same sign. Now we summarize the concept what we discussed above. So the first one what we discussed, okay, the first one what we discussed is, so let a b c belongs to real numbers and a not equals to 0, then the roots of the quadratic equation ax square plus bx plus c equals to 0. Okay, ax square plus bx plus c equals to 0 are complex numbers. Okay, if the roots are complex numbers, what happens? If the roots are complex numbers, what is the condition? Ax square plus bx plus c and the quotient of x square will have the same sign for all x belongs to R. Okay, if the roots, the first condition we discussed that if the roots are complex, okay, what we'll get? Ax square plus bx plus c by a. Okay, where the roots are complex means b square minus 4ac is less than 0. That means 4ac minus b square is greater than 0. Then we will get this total is greater than 0. When this greater than 0 ratio is greater than 0, when the numerator and denominator have the same sign. Okay, this is the first case we discussed. And what is the next case we discussed? The condition let ABC belongs to R and A not equals to 0, then the equation ax square plus bx plus c equals to 0 has equal roots. The next case is equal roots. When this will have the equal roots, that means b square minus 4ac equals to 0. The given quadratic equation will have the equal roots. If this is having the equal roots, then what will get again the condition as? Just refer the above statements. What is the derivation we did? This is again greater than 0. So that means the numerator and denominator will have the same sign. That means ax square plus bx plus c and a will have the same sign for all x belongs to the real numbers except at x is equals to minus b by 2a. Why? Because at x is equals to minus b by 2a this will become 0. Okay, and then what is the third one? So let a, b, c belongs to the real numbers and a not equals to 0, and having the quadratic equation ax square plus bx plus c has the real roots, and the roots are distinct, alpha and beta. If the roots are alpha and beta, so what it is, alpha less than x less than beta, we will get it as ax square plus bx plus c by a equals to x minus alpha into x minus beta. Then one is positive and another one is negative. So the roots are less than 0. The numerator by denominator is negative when the numerator and denominator are of opposite signs. So ax square plus bx plus c and the coefficient of x square will have the opposite sign, and here we have x less than alpha second case and x greater than beta. In these two cases, x less than alpha means x minus alpha less than 0 and x minus beta less than 0. In this case, the ax square plus bx plus c by a, okay, so both are negative, the product will results to positive. That means the numerator and denominator will have the same sign. Similarly, x greater than beta means x minus b positive, as well as x minus alpha is also positive. Then again we will get the ax square plus bx plus c by a, again it is greater than 0. Then the two cases, that means ax square plus bx plus c and the coefficient of x square will have the same sign. I hope that this concept of the sign of the quadratic equation with respect to the coefficient of x square will understand to you very well. Now we will discuss a simple trick, otherwise simple steps about the quadratic equation. Ax square plus bx plus c equals to 0 is a quadratic equation. Then if the sign of a and c are same, okay, if the sign of a and c are same, then how to find out the roots alpha and beta sign? Okay, that means if sign of a and c are same, then what happens it is, so what is alpha, what is product of the roots, alpha into beta is c by a. Okay, so now a and c are both are positive, positive by positive results as a positive, and negative by negative also results as a positive. So that means alpha and beta always will get it as a positive, the product of the roots always is positive. Only the case is both alpha and beta are having the same sign, either both are positive or both are negative, then we can say that the roots are, that means what is, the roots are alpha and beta greater than 0. Okay, so we can identify that in a given quadratic equation, the coefficient of x square and constant term are of same sign, then the roots will also have the same sign. Okay, if the coefficient of x square and the constant term have the different sign, okay, if these two are different sign, what happens, alpha beta is less than 0. Only the case is if alpha beta is less than 0 means that means alpha and beta must have opposite sign. Okay, alpha and beta must have opposite sign. Okay, I think you understand this. Simply nothing but in the given quadratic equation, if a and b, okay, that means sorry, if a and c have the same sign, okay, if the a and c have the same sign, coefficient of x square and constant term will have the same sign, then we can say that the roots are also the same sign. If the quotient of x square and the constant term are of different sign, then we can say that the roots are of opposite sign. Okay, thank you. In the next lecture, we will come with another concept. I hope that this lecture is very well understand to you and very useful to you. Thank you.